Okay, so here I'm going to do a video on the actual notes for sections 6.10 and 6.11. So the 6.10 is on just simplifying radicals, which we looked at in the foldable yesterday. So let's look at what the radical actually, the parts of the radical actually are. So the number out front, the little number that you put into the root here, this n, we call that the index. Okay, in a lot of the examples that we were doing yesterday, there was no number, right? There was no index showing up, and if there is no index written in, it is assumed that n equals 2, or the index is 2, or we're just talking about a square root. So if there's no number that's written in there, and I think you guys probably all know this, it's just a square root, okay? And then the actual symbol that goes around here is called the radical. Okay, so the radical, and then the number that goes underneath the radical we call the radicand. Okay, so those are the three parts of your roots. We have the index, the radical, which is the symbol, and the radicand, which is the number underneath. Okay, if a radical has more than one root, the radical sign indicates only the principal or positive root. Okay, so let's look at something that you guys need to work on memorizing, which I said in the video yesterday, is the first 12 perfect squares. Okay, I think I said yesterday the first 10, but might as well add in 11 squared and 12 squared. Okay, so most of these you probably already know. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared 25, 36 is 6 squared, 7 squared is 49, 8 squared 64, 9 squared 81, 10 squared 100, and then just 2 more that you might not already have in your memory, but it's good to get in there, is 11 squared is 121, and 12 squared is 144. Okay, so it's good to have those memorized. All right, and then this next section here talks about perfect square roots. So these are actually going to be you're going to be able to calculate these and get a whole number. Okay, so if we look at the first one, the square root of 81, which we know is equal to 9. Okay, and just like this says, if a radical has more than one root, the radical sign indicates only the principal or positive root. So here you don't need to write like plus or minus 9. For these purposes, we can just write the positive one, 9, the principal root. Okay, 2, this one is not in your not on your list, but the square root of 484 is actually 22. All right, so I'll let you do number 3 on your own, and then if we look at 4 and 5, so now we're dealing with numbers out front. So the only thing that's different is that these are just being multiplied together, right? So what we do is we write this as 18 times, and instead of writing the square root of 4, we'll just write the principal root, which is 2. 18 times 2, and that is 36. Okay, so same thing with 256. This is equal to 3 times the square root of 256, and you can use a calculator to help you with these bigger ones. 256, the square root of 256 is actually 16, so this is saying 3 times 16, which is 48. Okay, so you try number 6 on your own there. And then if we take a look at these roots here, is one of the rules I gave you yesterday. We can actually split this up into the square root of the numerator over the square root of the denominator, which the square root of 1 is 1, and the square root of the square root of 16 is 4. Okay, so this simplifies down to 1/4. Same thing with this one, the square root of 9 over the square root of 100 is equal to 3/10. Okay, So there's some of those. And then simplifying non-perfect square roots. Okay, so here they list the steps out for you here. Let's do a different color. Find the largest perfect square root that the radicand is divisible by. So what I had what I had said yesterday is we want to find factors of the radicand that are perfect squares. Okay, so this is essentially saying the same thing as what I was saying. Find the largest perfect square that the radicand is divisible by. And radicands are divisible by their factors, right? That's the definition of a factor. So this is just another way to say it. And then in the second part of step 1, it says break down the radical using this number. Take the square root of the perfect square and then take it out of the radical. Leave the leftover under the radical symbol. Okay, so let's do this again. We have the square root of 24. So let's see, factors of 24 that are perfect squares. So 4 is a perfect square and is a factor. So the other factor would be 6. Okay, so we write this as the square root of 4 times 6. And then we can split that radical apart to the square root of 4 times the square root of 6. And then simplifying, we get 2 times the square root of 6. Okay, so these are the ones that we practiced yesterday. Let's scroll down and take a look at perfect cubes. Okay, so these are going to work the same way. The only difference is the index, instead of being 2, is 3, so we're looking at cube roots. Okay, and the factors of the radicand, we want to, when we simplify, we want to look for perfect cubes instead of perfect squares. Okay, so let's write down the first 10 perfect cubes. Okay, so 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed, I'm running out of room, is 729, and 10 cubed is 1,000. Okay, so I would say you definitely should have the first 10 memorized for sure. But usually you'll be allowed a calculator with your homework and with your quizzes and tests. So it might be a good idea to just use your calculator to write down the first 10 cubes before you do any of these problems so that you know what factors you're looking for. Okay, so let's do a couple of these problems together. The cubed root of 8, which we know is just 2, right? 2 times 2 times 2 is 8. So 2 cubed is 8. We're just reversing that and we get 2. Okay, the cubed root of 729, well, that was one of the ones we wrote down here as 9 cubed. So the cubed root of 729 is just equal to 9. Okay, I'll let you do 24 on your own. This is where the cubed root gets a little bit different from the square root because we are allowed negative numbers in here, right? So the cubed root of negative 1 is equal to negative 1. Because if we have negative 1 times negative 1 times negative 1, right, a negative times a negative is a positive, and then we multiply it by a negative again, it's going to be equal to a negative, okay? So really with these negatives, it doesn't change anything. You're still taking the cubed root of that number, but the cubed root will be negative. Okay, so 343, we saw up here, that's 567 cubed. So we'll write 7, but since it's negative, it's going to be negative 7. Okay, so you can do 27 on your own, and then I'll just do 1 or 2 of these examples here. So 40, we want to split apart into factors that are perfect cubes, okay? So we're going to look at our list of perfect cubes up here and see if any of these are factors of the radicand here, 40. And 1 is not necessarily going to help us any because the other factor would be the radicand. So let's skip 1 over to 8. And it turns out that 8 is a factor of 40, 8 times 5. So we can write this as the cubed root. So don't forget your index if you're not working with square roots. 8 times 5. okay? Then we'll split it up just like we did with the other type, the cubed root of 8 times the cubed root of 5. We can simplify this to 2. The cubed root of 5 does not simplify at all, so it's just 2 times the cubed root of 5. And that is that simplified. Let's look at another one here. The cubed root of 500, okay? So you're going to have to get some practice in finding the factors of these numbers, but it shouldn't, the more you practice, the better you'll get. So here we have factors that are 125. 125 times 4 is 500, and so we know that 125 is 5 cubed. So if we split this up into the cubed root of 125 times the cube root of 4, we can simplify this to 5 times the cubed root of 4, and there's that simplified. Okay, so same process, just you're looking at different numbers for factors. Let's go over to our 6.11, our monomial square roots, which we also talked about yesterday in the foldable. Okay, so there are 2 rules here. One, if it's an even number, which we represent here by a multiple of 2, that means even number. And then if it's an odd number, which we show here as not a multiple of 2. Okay, so if it's an even number, if it's a multiple of 2, then when you take the variable out of the radical, you're just going to write it without the radical, and then you're going to divide the exponent by 2. Okay, so if we have like a to the 8th, the square root of a to the 8th, we can just write that as a to the 4th, which is 8 divided by 2. If it's odd, then we need to break it apart like this, where we have m minus 1 here, which is going to be like, for example, if we had a to the 8th, we write this. M minus 1 would be, oh, I'm sorry, we're looking at odd. Let's do a to the 9th. A to the m minus 1 would be 9 minus 1, which would be a to the 8th times a. So just like I said yesterday, we're just breaking apart one of them so that we can get an even one. And then we can write this as, we can break this off, this a to the 8th, which would be a to the 4th, and then we'll leave the last one underneath there. Okay, so I'm going to erase this, and then we'll look at a couple example problems. But like I said, we did these yesterday. Okay, so we have an even exponent here, x squared. So we take this out. We divide the exponent by 2. 2 divided by 2 is 1, which is just x. Yesterday I said if you're going from an even 2 to an odd 1, you need to include the absolute value. So the absolute value of x there. Okay, that's another even one. Here's an even one. Let's look at an odd one. These are all even. Let's just do one with multiple here. So 5, we have 100, and we have x squared and y squared. So like I said yesterday, we're going to look at the coefficient separately from one variable, separately from another variable, okay? And we're just going to look at each of these individually. So if we take the square root of 10, or I'm sorry, we take the square root of 100, this actually just becomes 10, so there's nothing left under the radical here. If we take the square root of x squared, we get the absolute value of x, and then if we take the square root of y squared, we take the absolute value of y here. Okay? So these ones are pretty straightforward. Let's look at y to the 5th. So we said we're going to break apart one of these y's in here, so we'll write y to the 4th times y. Now we have an even number. We can break these apart. The square root of y to the 4th times the square root of y. The square root of y to the 4th, we just divide the exponent by 2, which is 2. We're going from an even to an even, so we can write it as y squared times the square root of y. And there's an odd one for you. Okay, so it looks like most of these are just practice here. You want to summarize here at the bottom just kind of what the rules are for the different types of situations. If you have a perfect square, if you have a coefficient, you know, how do you simplify and all that stuff. Just kind of jot down some notes there.